Welcome back to Designing AI-driven Personalized Learning Environments course. In last video, we saw the drawbacks of rule-based model. To address these challenges or the limitations, we'll see the constraint-based model in this video. So the rule-based models forces students to learn a specific or predefined path which fails in open-ended and creative tasks. For example, writing essay or something like that. So instead of modeling how to solve the problem step by step, we should say that the solution should look like this. We just only care about the solution. Can we do that? That's a question we are asking. So the constraint-based model is born to address this problem. Instead of looking at the step by step, I want to look at the solution should have a proper this particular expected solution I'm looking at. I don't worry about how the student is arrived to the solution, but the solution is correct for the given kind of question. I'm good. For example, just simple analogy is that in a rule-based system, it's kind of a GPS where it says that you have to turn left in 100 meters, you have to go in this particular speed, you have to turn right. It tells exactly what to do at each tech steps. If you miss it, it will reroute again. It will tell that do it again. It gives exact feedback on it. It's like a GPS systems in our Google Maps. Whereas a constraint-based system, think about as a guardrails. It's not exactly the telling each step. It says that you have to start and you have to reach some particular destination. Drive whatever way you want, whatever speed you want. You can take a left or right, doesn't matter. But just stay between this particular line, stay between this speed limit. So it just say you have to stay within the speed limit. And if it also tells you not what to do, no. But it also suggests if you're not reaching a destination, if you're going in a complete opposite direction, it will say you are in the opposite direction. Because you are not doing something which is expected by the system. It is not telling you how to do the exact step, but it checks are you on the right path or not. If you're not right path, it gives the feedback. It doesn't care whether which steps you took it, which you did all the steps in the fraction. No, if your answer entered is in the right format, if it is yes, good. Otherwise, it will say wrong. Let's see some example here. It is proposed by Olson in 1992 IIT conference. The theory is that human beings don't learn perfectly following expert rules. For example, the idea of the rule-based model. The theory is that there is a set of cognitive rules. A problem can be break down to chunks, and you have to follow the chunk 1, then chunk 2, then chunk 3. There's a memory how the people learn it. But in the constraint-based model, the idea is that you don't need to perfectly follow the expert rules. We learn by making some errors and correcting them. It is not we learn by following the rule 1, rule 2, rule 3. That's the idea of it. So it's kind of contrasting. That's why I brought two different domain models here. It captures the domain principle that every solution should have it. For example, the constraint here is the two things, the CR, the relevance constraint, and the CS, the satisfaction conditions. So it captures the solution format should follow. For example, if you're driving in New Zealand, then you better be on the left side of the road. So that is the relevance condition. If driving in the New Zealand, it's a relevance condition. If you're doing something, you should be better left side of road. That is the be left side of road is the satisfaction condition. If you're doing this, you should follow this particular property. That's all. So for the relevant condition, you should have a proper satisfaction conditions. So constraint-based model is created, during this time where the rule-based model is getting popular. Some lecturers say that you should not teach everything by the rules. There are some particular topics we could teach without set of rules. The students can have multiple paths, but we check whether the outcome is correct or wrong. So it has been started and it has been popular. Why it is New Zealand? Because it has been used by Professor Tanya Mitrovic and from the University of Canterbury in New Zealand, and there's a tutor called SQL Tutor, and that's one of the system I know. Only one system know about using constraint-based model in developing intelligent tutoring systems or PAL. So we'll see bit detail about constraint-based systems. So in the constraints, there are two parts. We saw that in a previous one. The one is relevance condition. The second one is satisfaction conditions. In a relevance condition, it's a kind of a if rule, as we saw in the production rules. Satisfaction conditions are then rules. If this constraint applicable to a student is doing right now, then the student work meets the required principles. That's all. If relevance is true, then satisfaction must be true. Otherwise, trigger feedback. That's a logic. We'll see the examples in next video. Thank you.